Good afternoon. Welcome to the World Manufacturing Forum 2020 North America edition. And thank you so much for joining us. We have the prestigious Kenneth Swope as our next guest. Welcome, Kenny. Very nice to meet you.
Nice to meet you as well.
If you don't mind, I'm going to take just a moment and read your bio so that our listeners will know who you are and where you come from.
All right. Fantastic.
Kenny Swope leads Boeing's engineering practices, processes, and tools integration team and is responsible for the organization which oversees the integrated set of architecture products that describe Boeing's multiple lines of business. With over 26 years at Boeing, Kenny contributes technical oversight to business requirements, value stream definition, performance measures, business data, and process management. In addition, Kenny is chair of the ISO TC 184 ST4 industrial data, where over 700 international standards critical to product data definition, interoperability, and smart manufacturing are defined. Kenny is recognized as an expert in multiple ISO IEC activities around smart manufacturing, digital twin, and machine readability standards. Kenny holds a master's degree in engineering management from Washington State University, a Bachelor of Science degree in mechanical engineering from the Missouri University of Science and Technology, and a Bachelor of Arts degree in physics from the University of Central Missouri. Outside of Boeing, Kenny is active in his local 4-H organization through Washington State University as a technology program leader and mentor to teams in FIRST Robotics and FIRST Lego League. Very impressive. Thank you so much for joining us. I can't wait to hear your presentation.
Hello, and thank you for that warm welcome. I'm Kenny Swope, as the introduction notes, and today I'd like to share with you some comments and thoughts around value-based standards. My thanks to the World Manufacturing Forum for giving me the opportunity to speak to you today, and let's get started. So before I begin, just a couple of comments about the Boeing company. I am in the engineering department at Boeing. And Boeing, being a global corporation, serves commercial airplanes, global services, defense, space, and security, and we have a capital financing arm with worldwide operations and manufacturing in multiple locations. The role of standards is very important to the company, and the role of manufacturing is critical to the company's future. So a little bit about my agenda today. I'll start off with just a quick introduction of international standardization and talk a little bit about the standards that we have in industry around this space for product data and manufacturing. And I'll talk a little bit about standards at Boeing and some comments about the role of standards in Boeing's business. And then I will talk about some industry collaborations, some that have been around for a while and some that are new, and then conclude with some summary remarks. To start off with, just a quick comment about ISO, the International Organization for Standardization. I suspect many of you are familiar with ISO. It is a international organization that develops standards at an international scale. It consists of 162 member countries and really strong foundation of national standards bodies from around the world coming together to promote the very best in standardization. Inside that framework, ISO TC 184 SC4 industrial data is the committee that I'm the chair of. And the focus of this committee is all about the product and the product life cycle. You can see there we have 769 standards in scope with 32 projects underway, multiple groups that are working with experts from 17 nations directly and then 14 nations that observe. And I'm pleased to share that we recently moved to 18 participating members with the inclusion of Canada joining us here recently. Just a little bit about the standards that we manage in SC4. You can see here they're organized, and what I've done here is put them in a value stream context. This one resonates, I think, with many who deal with the product design and the product data in manufacturing. Product definition, visualization, factory integration, and digital manufacturing with foundations in data quality and product properties and classes. The standard that probably we're most famous for is ISO 10303, commonly known as STEP. The STEP standard has many parts that support the definition of the product, the communication of the product design from an interoperability perspective across domains and IT applications and the supply chain. Chances are, if you're in manufacturing, you have exchanged a STEP file with someone in your supply chain. But then STEP is not the only thing that's in the committee. We also have 15926, which is a standard for the oil and gas industry, and really extends the idea of STEP to the classification and identification of components in refineries, on platforms, in large asset industries. We also have JT. JT is ISO 14306, and several new visualization standards that are coming forward in 17506, 23301, 24464. Factory integration is all about how we take the product and the product design and flow requirements from it into manufacturing, and you can see several listed there. And then digital manufacturing, which is an exciting new area of growth for us, and I'll talk a little bit about ISO 23247 and share some thoughts about digital twins. At our foundation, though, is a really strong core of data quality with ISO 8000. It forms a quality management system for data, if you will, and then product properties and classes with 13584 and 22745, which are largely databases, if you will, of products and their characteristics that are available for reuse and public dissemination. But turning my attention to 23247, I'm really excited and would share with you something that I think would apply directly to anything that you're working in a manufacturing context. We've known for a long time that the machines on a factory floor need to be able to communicate, and as they grow smarter, they grow more instrumentation, more ability to measure, monitor, provide feedback, adapt real time. There was a need for standardizing the communication framework for them. So ISO 23247 shows a technical framework and then an implementation approach. And it provides us a means for establishing how the communication should occur at each level, from the physical device itself through the data collecting and controlling to the distribution and communication, and then finally to the, if you will, the supervisory or control system. And you can see an implementation shown here where, different machine types are characterized in the observable manufacturing space that feed into manufacturing systems, manufacturing operations systems, and then supervisory control systems that feed factory operations and leadership decision making. We're actually demonstrating this, and we've got two examples that I'll show. The first one here is actually pretty close to home for me. Boeing is sponsoring research with the BARC Lab, which is the Boeing Advanced Research Center at the University of Washington, and several companies that are participating in the research. And the idea here is, if you're familiar with how aircraft are produced, you know that very large machines are often used to assemble wing panels and create aerostructures. With this example, instead of a very large, very expensive machine, we instead are using 4 robots. And the 4 robots are very flexible, they're very dynamic, and they coordinate with each other to build a small wing panel assembly for this demonstration. They are Kenny, Kyle, Cartman, and Stan. And what they're doing is proving the test case here of dynamic scheduling. And what happens when one of these robots suddenly goes offline for a manufacturing related issue, or the robot itself, perhaps it breaks some component? We don't want to lose the investment we've made in the assembly so far. So in this example, the robots self-monitor and report back to a supervisory control system that reallocates and retasks the other 3 robots to complete the jobs. And if you know something about robot programming, you know that that can be very complicated, lots of stay-out zones, safety zones. But the use of standards, and in particular 242, AP 242, is what we call for ISO 10303 Part 242, in conjunction with MT Connect and various other protocols. We are demonstrating this at the BARC lab. My second example comes from machine tool cutters. So Kennametal is doing this research, and in this case, what we're doing is demonstrating the use of the standard for machine tool optimization and predicting when a cutter needs to be changed out. And so we're getting the most use out of a cutting tool, optimizing the cutting tool paths for the most high quality geometry in cutting, and providing real-time feedback to a supervisory system and data for applications like AI and machine learning. And across the bottom here, you can see sort of the steps that are taken, going from G-code operations, which is the actual machine tool itself, through, again, an MT Connect communication protocol for the streaming of the data to a real live model of the same part, and then applying the results of the cutting tool model, and then step in C, adapting the cutter paths and providing the data back to the machine. You can see here a possibility of 15% increase in tool life by using this process. And of course, we're just in the example stage here, but I'm truly excited about this. Turning my attention to Boeing for a minute, we've been in the PLM business and the digital business for a very long time. And this chart here is really meant to convey that as a company, we have been through the entire learning of digital and digital use of standards for digitalization and modeling. And I'll draw your attention, well, I won't talk to every element that's on this chart. I'll draw your attention to the right-hand side of this chart, where we talk about our future state. We've been modeling for a very long time, and very, very expansive, very complex models that we use in the development of products. And so what we're looking for the future is to how to fully leverage and utilize these. So going from 3D model-based definition to a persistent digital twin, for example, going from change paper that, quite frankly, still exists in electronic records to a model-based approach with the utilization of more advanced COTS platforms. Really taking advantage of simulation and the Internet of Things to drive simulations and feed data back to simulations. Looking at the bill of material and how multiple organizations take advantage of the bill of material for their use, not just product design, but the manufacturing, the service and support, and the maintenance of the product out in service. All the way to even technologies. We're taking advantage of more software as a service platforms, and cloud. So when we talk about going from now to the future state, you might ask, well, what is the role of standards in this? We talk about standards in a very particular way. I don't think it comes as any surprise that COTS platforms is the industry trend. Everyone is using COTS applications to further their work and to provide value. And for the longest time, we talked about integrated architectures, where you developed a solution for a particular program or a particular product line. That's moving more towards platforms. So if you think about PLM as a platform, ERP as a platform, manufacturing operations as a platform, these now embody many services within those platforms, and it's all good stuff. The key is to ensure that we always have a way of integrating and accessing the data. And it's in this space that the role of standards really become key. And on the right-hand side, you can see, for example, this is what we call a radar chart. And while you're not meant to read every dot that's on it, what it conveys is the set of standards that Boeing's been tracking for utilization in this space. And we have standards, of course, that we adopt directly. We have standards that we monitor. We participate in quite a few. And then, of course, there are some that we still continue to develop on ourselves. The point behind this is that these standards play an integral role in federated platform systems. And they really provide a unique opportunity for platforms, especially in a supply chain, to interact with each other in a way that doesn't require direct connection, and you have to use my PLM because I'm the OEM, for example. So we really are looking forward to this and embracing the use of standards from an architectural perspective. But we also know that standards require really a village, requires an ecosystem of participants for a standard to really be the best. And the chart that I'm showing here is one that I've pulled from some collaboration that we do with PDES. PDES Inc. is an organization that we participate with. And in the PDES Inc. Structure, there is this concept of user community, an implementer forum, and a standardization community. And the reason I bring it up and why it's relevant to our topic today is that you need all three for a standard to be really the best that it can and to serve industry requirements in the most efficient manner possible. We'll begin with the user community. So, for example, I representing Boeing into one of these groups would have a set of user requirements and use cases that I need solutions for. That's shared both with the standardization community. It's also shared with implementations, implementers, software developers, organizations that provide middleware. The implementers in the standardization community work with each other to build the most efficient standard possible to satisfy those needs. And then the implementers themselves work on best practices that will take those standards and demonstrate their implementation in their particular tool set. PDES as an organization helps facilitate several of these, and you can see the forums that are structured, and that's on the right-hand side of this chart. The interoperability forum for CACs, so this one's been around for quite some time, it's been quite successful, but there are others as well for computer-aided analysis, engineering, electrical wiring, wire harness, and PDM. And these organizations actually are easy to join, and definitely from a user community perspective, I would encourage you to find out more about it and come share with us. So in closing, my three main points that I hope you got from my talk today. The first one is that standards exist in every aspect of manufacturing, whether you're building a design for manufacturing, you're building the product, you're trying to figure out how to construct that product, to manufacture that product, how you're trying to figure out how to source that in a supply chain context. The standards are a key to simplifying your approach. By standardizing on how you're going to communicate, you actually enable value within your own organization. The standards are referenced in most contracts. So if you look at your contracts, you'll note that there's probably some communication about how you communicate data up and down your supply chain. I would invite you to look at those. Oftentimes, they are something that you can leverage for your own use, and look at what kind of diversity of standards you're currently living with today. And then finally, standards exist to satisfy your needs. And I hope you saw that the way Boeing is looking at this, that there is lots of opportunity for not only using standards in your organization, but also contributing back. And there's many ways to do that. You don't have to be a Boeing to do this. You can join industry consortia, academic partnerships, and contribute to that knowledge base. Those are my remarks. I thank you for taking the time today to hear what I have on standards. I hope you found it useful and helpful. And I am always available for follow-on conversations or questions that you may have. Just drop me a line and I'll be happy to follow up with you and share more about it. With that, I'll say thank you and have a great day.